So what is a stream? So a stream is just an ordered sequence of bytes, right? So byte 0, then byte 1, then byte 2, then byte 3, then byte 4, right? It doesn't matter what a byte is, right? So byte some number of binary bits, right? So you can think of it as just being 8 bits, right? So it's just a sequence of 8-bit chunks of data, right? The actual number of bits changes depending on your computer architecture, right? Most people think a byte means 8 bits, but that's not exactly true. It's close enough for our purposes. Okay, so programs can read the stream. So you can look at, say, byte number 4, right? And similarly, you can write to a stream. So for example, you can change byte number 8 in the stream, right? Now, the interesting thing that you can't do in Unix is that you cannot delete a byte and you cannot insert a byte, right? So a stream's not like a list, right? You can't insert into the stream. You cannot remove from the stream. Right, so don't think of it as being like a Python list or a Java list, right? It's the closer analog is something like a Java array. All right, so Unix has 3 standard streams that you can connect to, right? So the standard input stream, that's the stream where your computer can read data from. Sorry, your operating system or your shell can read data from, right? So standard input is normally connected to the keyboard if the computer you're working on has a terminal of some kind, right? If your computer doesn't have a terminal, then standard input might not be connected anywhere, right? No terminal, no keyboard, therefore no standard input, right? Standard output is the stream which output normally goes to, right? So on a Unix-like system, standard output is normally connected to the terminal, right? Type something in, it shows up in your terminal, right? Standard error is the stream in which programs can write error or diagnostic output to, right? And again, on Unix-like systems, standard error is by default connected to your terminal, right? So if you get an error message, typically it shows up in your terminal. Right? Okay, every stream, these are the standard streams. The user is able to create their own streams, right? And so for the operating system to identify which stream does it need to use, it assigns a integer value to the streams, right? And so standard input gets the value 0, standard output gets the value 1, standard error gets the value 2, right? So if you say if you say do something with stream 0, you're talking about standard input, right? Do something with stream 1, you're talking about standard output, right? If you create your own stream, say stream 100, right, and you do something with that stream, you're going to write to that stream. That stream might be connected to a file, in which case you can read and write to a file, right? And that's exactly how it works in Unix. Sorry, I don't know why this is here. Skip this slide for a second. That's an erroneous slide, sorry, which I've never removed from the deck. Okay, so pipelines. On the first day of class, I think, or the second day of classes, I showed you how to write a pipeline, right? And so you can think of a command in Unix as being a section of pipe, right? On one end of the pipe is some input, and on the other end of the pipe is some output, right? So in other words, a command accepts some either 0 or more pieces of input, right? And it produces some output, right? The input could be a stream, and the output could be a stream, right? So for example, input can take the form of a command line argument, right? So ls, my command ls, right? You might write ls/bin. So your /bin is an argument to the command, right? So we think of that as being an input to the command, right? ls generates a stream of text, right? It generates a stream of text showing you information about whatever is in the bin directory, right? Now the input could come from somewhere else, right? So many Unix commands, so sort is one of these commands. So remember I showed you sort by passing in a file. So sort some file, it sorts the lines of the file, right? But it turns out sort can also read from standard input. So if you don't give sort a command line argument, sort thinks you want it to read from standard input instead. So for example, sort, none. Hang on, let me see what's in this directory. I have no idea where I am. Oh, I'm in one of the assignment directories. Is there anything in A1 solution? No, nothing there. All right, so sorry, I have to find a file. Let's do class list because I know there's a file there. Okay, so I know that, so if I sort this class list, right, it reads the contents of this file and sorts it line by line, right? So here it's going to sort by, in this case, so it sorts line by line. So in this case, it's sorting, it looks like it's sorting by the student number. You have to be a little bit careful. It's not exactly, that's not necessarily what it's doing, right? It's sorting alphabetically, right? So in this case, it happens to sort by the student number. You have to be careful about that, right? If you have a file that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you sort, well, let's make that file and show you what happens. It's all right. If you're interested in what this program called VI is, it's one of the common terminal-based text editors. It's clunky to use. So I never show you how to use it because you have to remember how to do things like enter text. There's a command that you have to use to enter text. There's a command that you have to use to delete text, and so on and so on and so forth. So it's not the easiest thing in the world to use, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, if I sort that file, it doesn't do what you want it to do, right? Remember, sort is going to sort alphabetically. So 1 shows up first, and then 1, 0 shows up next instead of 2 showing up next, right? This is not sorting numerically. So you have to be a little bit careful about sorting stuff if you're sorting by number, right? The classic computer science way to solve this problem is to insert a 0 in front of all the ones, in front of all the single digit numbers, right? So 0, 1, 0, 2, 0, 3, 0, 4, then 10, and that will sort now numerically. It's still sorting alphabetically, right? So be a little bit careful about sorting numeric stuff. This is so common, in fact, that if you do man sorts and look for one of the options, n, right? You can actually ask sort to do a numeric sort instead, right? So if you know that the first thing on all of your lines is actually a number that a normal person would write down, and you want to sort it, you might want to use -n instead. Okay, so sort, if you pass it nothing, thinks that you want to sort the lines that someone's going to type in, right? So now, let me start typing in some numbers. So 5, right? Press enter, nothing happens, right? 8, nothing happens. 1, nothing happens. 2, all right, enter. Okay, so it looks like this is going to run forever, right? And it is going to run forever. So what you have to remember is that sort is taking its input from standard input, which is the keyboard, right? And so it needs to know, when does this stream end, right? Or when does the current stream of data end? So you have to tell it that the current stream of data is going to end. The way you do this, if you're entering in input directly from the command line, right? So you're doing this interactively, it's Control and D, right? And so as soon as you press Control D, that indicates that this is the end of the stream of data, and now it sorts what you typed in, right? So now you get 1, 2, 5, 8. Right? The slide tells you this exactly, right? So Control D signifies the end of input. Right? So if you're using a command that is reading stuff from standard input, you probably have to hit Control D at some point. Or the command has to be aware of some special character that you're going to use to end input, right? Some command line programs will say press Q to stop, right? And so you press Q to stop. Calsay will also take its input from standard input, right? Oh, sorry. So Calsay, right? Press enter, nothing happens, right? Hello world, right? Enter, Control D, and now you get hello world, right? Okay, the output of a command usually goes to standard output, right? So for many Unix commands, right, when you run the command, it just prints stuff out to standard output, right? So sort, by default, sends its output to standard out, right? So it prints anteater, dog, elephant, zebra in this case, right? If there is an error, right? So for example, if you type in the name of a non-existent, the path name of a non-existent file, right, and ask ls to display information about that file, you get an error message, right? ls blah, right? And ls says can't access blah, there's no such file or directory. Right, now remember, this looks like it came, so this did get printed to the terminal, right? But it turns out it got printed to this stream called standard error, which is different than standard output, right? So error messages typically go to standard error. Standard error happens to be hooked up to your terminal, therefore it shows up in your terminal. Okay, so the user can change where output goes, right? And so either where output goes or where input is taken from, right? And so this process is called redirection, right? So redirecting standard output or standard error lets the user send the output of a command somewhere else. So for example, instead of printing the contents of a directory using ls, right? You can list the contents of the directory and send that to a file, right? Or instead of sorting the contents of a file and printing it, you can sort the contents of a file and save it to another file, right? That sounds a little bit more useful than saving the output of ls, right? You can also redirect standard input. So that lets you send, if you redirect standard input, then a command that is expecting to read from the keyboard can now read from a file, right? So you can redirect a file to the standard input of a command. So redirecting standard output, this is the most common one, right? It's somewhat uncommon to redirect standard in, right? So to redirect standard output, right, what you do is you say 1 and then the greater than sign, right? No space in between, right? And then you're going to specify a file name, right? So the 1 means, remember 1 corresponds to the stream identifier for standard output, right? The greater than sign is the redirection operator, is the redirection operator in bash, right? You're going to redirect to a file, right? So that will, you can put this anywhere in the command, which is weird, right? Anywhere in the command, that will redirect the output of the command to your file, whatever file name you give, right? When you do this, right, it will create the file and then write the contents of the output to the file. If this file already exists, it overwrites the contents of that file, right? And overwriting the contents of a file in Unix is irreversible, right? So once you overwrite a file, your original file is gone, right? The contents of the original file are gone, right? Okay, so for example, I would like to list all, right, all of the files in a directory except for dot and dot dot, right? And I would like to send that output to the file files.txt instead of printing it out. Is there anything interesting here? There's not a lot interesting here. So ls minus a, hang on. The touch command, I don't think I've shown you this yet. It's in one of the notebooks that I skipped over and I'll come back to. Touch will create a file, create an empty file having that name, right? If a file of that name already exists, touch changes the modification time of the file, right? So you can use this as a simple way to indicate that a file has been modified. Okay, so ls minus a says there's a file called hidden, dot hidden, there's a class list file, there's a numbers file, right? ls minus big A 1 greater than files.txt, right? We'll run the ls command, right? Take its output, or take its standard output, and redirect that to the files.txt, right? So now there is a files.txt, right? If I look at the contents of files.txt using cat, right, you can see there they are, right? So there's hidden, there's your class list, there's your files, and this is interesting, right? Sorry, there's numbers.txt, and this is the interesting part, there's files.txt, right? And so when you redirected the output to this file, right, it looks like that file got created before ls actually ran, right? Because it shows up in the output of ls, right? Is this guaranteed to happen? I have no idea if this is guaranteed to happen. So I don't know if the file gets created before or before the redirection occurs, sorry, I don't know if files gets created before ls runs, right? Or can it be the case that ls runs and then the file gets created? Right? Somewhere that's probably documented. I don't actually know what the answer is. But here at least, it created the file first and then ls ran, or ls finished running and produced the file. Notice the other funny thing here. Right? When I just ran ls on its own, like that, right? The output produced by ls does not, it outputs all of the files on one line, right? But when I look at the contents of the file, each file name appears on its own line. And this is one of the funny things about ls. So the output that ls generates depends on whether or not it's going to the terminal, or whether or does it go to, or has it been redirected somewhere else. As soon as you redirect it somewhere else, the output is looks like one file per line, right? When you do assignment 12, when you do question 12 on assignment 1, you'll hopefully realize that it's not necessarily one file per line if there's weird characters in the file name, right? But ls is strange. Its output changes depending on where it's going, where it goes to. Okay, so when you redirect output, typically you mean redirect standard output. So if you don't put the file descriptor in, bash assumes that you're redirecting standard output, right? Oops, sorry, right? So ls minus a, no 1 this time, right? So just the greater than sign, right? That does exactly the same thing as the previous example, right? It redirects the output of ls minus a to the file files.txt, right? So if you run that, it's exactly the same thing. So you don't need to put in the 1 if you're redirecting standard output. Any command that sends its output to standard output can be redirected, can have its output redirected to a file, right? So there's calc. It prints out a string using a dragon. That's what the -f dragon does, right? And it redirects all of that to the file mu.txt, right? You can type that into your terminal and see what it does. It does exactly what you think it does, right? When you redirect the output, remember, you don't get the output of the command, right? So calc hello, redirect to cow.txt, right? It doesn't produce the output to standard output as well, right? It all went to the file instead, right? Look at the file using cat. There's the output. Okay, if you don't want to overwrite the file, but you want to add to the end of the file, then you use the double greater than sign, right? So this means don't overwrite, append instead, right? So 1 greater than would append to files.txt, right? Greater than appends the standard output of ls to files.txt, right? If I do this with calc, so calc hello again, oops, sorry, hello again, right? And double greater than to cow.txt, right? Again, no output to the terminal because we redirected standard output to a file. If you look at cow.txt, right, it added to the end of the previous output, right? So there was the original output from calc the first time I ran it, right? Then I appended the output from the second instance of calc, and there's the output there. Right. If you want to redirect standard error or any other output stream, you must put the stream identifier in, right? So if you want to redirect standard error, you must put in the 2, right? So 2 greater than error.txt sends the output of ls. It sends the error output of ls to error.txt. The standard output of ls still goes to wherever standard output is connected to. So in this case, it would go to the terminal. Do I show you an example of that? Yes. No, there. Okay, so let me show you what I mean by that. Okay, so here I've got 4 files, right? So if I do ls cow.txt, I know that I get some output, right? Non-existent, right? If I do this, you know you get an error message, right? Okay, so what if I do both? Non-existent, right? And I redirect the standard output to some file. So I'm going to output to temp, right? Okay, so I didn't redirect standard error, so the standard error message still shows up on my terminal, right? I did redirect standard output, right? And so the ls cow.text part should be in temp.text, right? And in fact, it is, right? So here, right, remember what ls does, if you give it multiple files, it lists the information about each file, right? So does cow text exist? Yes, it does. So ls generates that output there, right? Does non-existent exist? No, it doesn't. So ls generates the error message here, which went to standard error, which is connected to my terminal, and I didn't redirect standard error, right? You can redirect as many streams as you want. So if your program happens to output to many, many streams, you can redirect any one or combination of those streams, right? So here, I'm going to redirect standard output to files.txt. I'm going to redirect standard error to error.txt, right? So this command will produce no output on the terminal, right? Any existing files will be listed in files.txt. Any error messages will go to error.txt. Okay, what about redirecting standard input? I think for the purposes of this course, you can ignore this. Normally, you're not going to do this. It's somewhat unusual that you would have to do this. So if you want to, you can redirect standard input, right? So reading the contents of a, So instead of reading from the keyboard, right, you can read the contents of a file instead, right? Because remember, standard input by default is hooked up to your keyboard. So if you write 0 less than some file name, right, the contents of standard input now takes its input from the file instead, right, rather than reading the keyboard, right? The 0 here is just the file descriptor, right? So sort, we know, so I showed you sort will read from standard input. Right, so again, sort on its own, right? 2, 3, 1, Control D, right? So sort will read from standard input. So if I wanted to have sort read from a file, I could. Okay, what's numbers? Hang on. Okay, so if I want sort to read from a file, you could, if you wanted to, write sort 0 blah numbers.txt like that, right? Which is sort of gross, right? But it does work, right? So it does, in fact, take its input from numbers.txt and output, the sorted contents. Notice I have a blank line in that file. So the blank line shows up first, right? The empty string is the quote unquote smallest string. So they will always show up first, right? So this not only looks weird, it is weird. Most commands in Linux, if they can read from standard input, will also read from a file itself. Right? Oh, sorry, it's not in the slide. Right? So instead of writing sort 0 less than numbers.txt, most commands that read from the standard input will read from a file directly. So normally you don't have to do this sort of thing. Because standard input is if you're redirecting input of some kind, normally you're redirecting standard input, right? So you don't need the 0 here, right? If you leave it off, it assumes it's 0, right? If you want to, you can redirect all the inputs and all of the outputs for a command, right? So here, sort, I'm going to redirect its input so that it reads from unsorted.txt, and then I'm going to send its output to sorted.txt. Right, so there's the redirection for the output. There's the redirection for the input. Okay, pipelines. So there is the last few questions on the assignment are pipelining questions. But I showed you how to write a pipeline in the first couple of lectures, right? And so using this pipe analogy, it makes it a little more clear about what a pipeline is doing, right? You can connect to the output of a command to the input of another command using a pipeline, right? The single vertical bar means take the output of this, send it to the input of this, right? So here I can list the contents of bin, right? And redirect the output to the input of less, right? And less is a program that will let you, that displays text one screen at a time, right? ls root bin, right? Notice a whole bunch of stuff here, right? How many files are here? Well, I can use a pipe, right? Send the output of ls to a file called wc, which is word count, right? Word count will count the number of bytes, words, so things separated by spaces, or lines in a file, right? Let me just do it this way, right? So that tells me that's the number of lines. Sorry, is that the number? Yes. Hang on. Is that the number of lines? I forget what the order is. Yes, that is, sorry, so I guess one of these is the number of lines, right? So there are 11,000 commands in my bin directory, right? So there's a lot of stuff there. If I actually wanted to look at that output, right, I can pipe the output of ls to a command called less, and less lets you look at the output one page at a time. So there's the first page of results. If I press space, I can get the second page, third page, fourth page, and so on and so on and so forth. Right? This is only useful if you don't have a massive amount of output, right? But you have more output than will appear than you want to look at on one screen. Okay, so another example of a pipeline. So I can run the fortune command. Fortune outputs some random fortune, right? And send its output to the cowsay program. Cowsay will then do its thing with the string that it gets from fortune and print the fortune using a cow, right? Come on, there we go. So fortune on its own, fortune on its own outputs a random fortune, right? If I want the cow, or use a cow to output the fortune, I can use cowsay instead, right? And you can connect as many commands as you would like, right? So I can run ls, right? Take that output and send it to sort, right? And then take that output and send it to less if I wanted to, right? So ls runs. There's something I always forget to mention. When you have commands set up in a pipeline, right? It's not the case that this command runs first, then this command runs second, and then this command runs third, right? So that's not guaranteed to be the result, right? So if your first command generates a file, right, and your second command reads from the file that was generated, there's no guarantee that the first command generates its file before the second command tries to read from that file, right? So you have to be careful about that. So what's going on here is that this command is running, this command is running, this command is running. This command generates some output, right? And the output of this command gets sent to sort, right? Now, if sort is running before this, sort is just going to wait, right? Because it's expecting its input to come from whatever the output is here. So sort will wait for ls to generate its output, and then sort will produce its output, right? Similarly, less is going to wait for the results earlier in the pipeline. So ls root bin, root user bin, pipe to sort. So this is going to sort the output and then send the output to less, right? And so when you do that, you're going to see that, so there's the output of bin. There's the directory name of bin. There's the directory name of root user bin. And then notice that there's a bunch of repeated files, right? And so it turns out that on at least my Linux system, the directory bin and the directory user bin, it turns out they're both the same directory. And so they both contain the same contents. Sorry, they're not necessarily both the same directories. One directory is the same as points at another directory is what's happening here. Right? So how many files are in total are in the two directories? So I can list the contents of both directories. Right? Send the output to sort, and then ask the word count program to count the number of lines in the output. Right? That's going to output something like 2,000 and something on my computer. Right? Now, how many unique files in total are in the two directories? Right? So again, I can list the contents of both directories, send that output to sort. Right? If there are file names that are the same in both directories, they will appear one after the other. Right? The unique program removes repeated lines, right? So if you unique will remove repeated lines where repeated lines are adjacent to one another, right? So if you have a line with A and then another line with A right after it, unique will replace it with one line that has an A on it, right? If you have A, then A, then A, then A, unique will replace it with one A, right? If you have A, then B, then A, you still get A, B, A, right? The lines have to be adjacent for unique to remove them, which is why I'm sorting it first, right? So by sorting it first, I guarantee that unique will remove the lines, the repeated lines, right? And then finally, I can send the output to word count, right? And that will tell me the number of unique file names in the both directories, right? If you want, you can ask unique, instead of removing the unique lines, right? Give me back the duplicated lines, right? So that's what the -d does, right? And so that'll tell you how many duplicated file names there are in both directories, right? And that's how you write a pipeline, right? So a pipeline, you just connect the output of one command to the input of another command. The last 3 questions of the assignment basically have you write increasingly complicated pipelines, right? Using the cut command, basically. Right. All right, any questions about today's lecture? How about, oh wait, what time is it? Oh. Okay, we got a few minutes. Any questions about the assignment that would be useful for everybody to hear? Okay, question?
Oh, you said it's not guaranteed. Is there a way to force the priority?
Force the priority of?
In like the pipe?
Oh, no, there isn't. No. Yeah. Yes?
When doing question 1 of the assignment,
yeah.
Does it matter what you're using?
Oh, no. The output for everybody's gonna be different, right?
Okay.
I just want the absolute path name.
Okay.
Right,
and
so root, blah, 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 blah. That's it.
For question 6,
yeah.
It says in the example, it's like, it'll be like, you laid like a capital A1 answers, and then it'll be like a lowercase a1 answers.
Yep.
If it's like, if you have something that's like capital A, and then capital A, and then lowercase a, but then it works the exact same way as expected, does that matter?
I don't understand your question. I can't visualize it, sorry.
Like question 6 asks the list, like, any files with lowercase a and uppercase a, correct?
Yeah.
So if you have...
I see. So the question is slightly ambiguous because depending on how you write your command, you might get the lowercase a's out first. It doesn't matter.
In your output, it says lowercase a's first.
It doesn't matter.
For me, for example, it'd be uppercase.
That's fine.
Does that matter?
No, okay. Doesn't matter. Any other questions? Super. You now have all the information you need to complete the assignment. Technically, it's due tomorrow, but remember, you got the extra 3 days, so you can hand it in by, I guess, Monday?